Week 9, Graphing Exponential Functions. Now we've been working with exponential functions for a while, and now we're going to see what they look like when they're graphed. Now a is the starting value, and that's really what you think of in word problems, but for graphs it's actually the y-intercept, so it's going to be the first point that we would plot. Now that b value is going to determine if your graph is increasing or decreasing. The way that you know is if that b value is a number that's greater than 1, that's increasing, so that's growth. If the b value is between 0 and 1, then it's going to be exponential decay. Now that means things like fractions and decimals. We are not ever going to have a negative b value on this. So let's take a look at example 1. Okay, my a value is the number on the outside, that's 3. My b value is the number inside the parentheses, that's 2. Now that a value right there is actually your y-intercept. So if I were going to graph this thing, we've got our vertical y-axis, we would put a point at 3 right there. Okay, that's my y-intercept. Okay, so here's what's actually happening when we have this problem. We're starting off with 3, and we are going to be multiplying by 2. So my next number that I would have right here is 6. Then I'm going to be multiplying by 2 again, so that number inside the parentheses is just what we are multiplying by over and over and over again. This one would be 12, so if I went over here, the next number we'd have, oh, there it is, it's 12. If I continued one more time, times 24, that would be all the way up there. Yep, it does cross at 24. So that is this line. Now I'm going to talk about this green line that I have drawn on here on the next example. But since this is exponential growth, that means that we are increasing from left to right. So that line is moving up as you go from left to right. Example 2. My a value is 8 because it's outside of the parentheses. My b value is 1/2. So my 8, that very first number, is just going to be the y-intercept. So it's where you start on your y-axis. Now that 1/2, this time, that's a number between 0 and 1. It's not bigger than 1, which is why this is exponential decay. It's decreasing. Because here's what's actually happening. We have 8, and we are going to multiply it by 1/2, which gives me 4. So my next number would be right here. Then I'm multiplying by the fraction 1/2 again, which gives me 2. And then if I multiply by that fraction again, I get 1. If I do it again, I've got 1/2, and it's just going to keep going. Now, why I'm still going is because this line is actually going to keep going forever and ever and ever. It looks like it touches the x-axis right here, but it actually doesn't, because that would have to mean that our value is 0. Now, 1/16 might be a very small number, but it's not 0. And even if we had 1/16, and we continue to divide that by 1/2 over and over and over again, I mean, not divide, multiply by 1/2, that gives me 1/32, which is an even smaller number. So our numbers are going to get very, very small, but they never actually equal 0. This line right here that it doesn't cross is called the asymptote. And in Algebra 1, it's always y equals 0. Now, we're not going to talk a whole lot about that, but I did want you to know that word. Okay. So this one was exponential decay because that number is between 0 and 1, which means that our line is decreasing from left to right. Okay. So since we are doing this on the computer and not in class, it's kind of hard for us to have you graph them. So what we're going to do instead is more of matching. So example 3 says, which of the following graphs best represents the exponential function f of x equals 4 times 2 to the x power? I know right away that that number in front of my parentheses is my y-intercept. So this one has a y-intercept at 4. That's okay. This one has a y-intercept at 4. That one works. But this one has a y-intercept of 2. It's out. This one also has a y-intercept of 2. It's out. So I got rid of half of my answer choices just from that by being able to tell what the y-intercept is. Now I've got to figure out if my line should be increasing or if it should be decreasing. Well, this number inside the parentheses, that number is greater than 1 or greater than 1. Because that is a number that's greater than 1, that means that we are dealing with exponential growth. So that means our line, if it's growth, should be increasing as it moves from left to right. So this one would be answer choice A. Now you can graph these in your calculator to see if they look kind of right. But a lot of the times what you're going to discover is that the calculator doesn't have a big enough screen for you to see all of the information. So that's why I'm showing you how to do it just from the numbers. Also, because I know a bunch of you do not have calculators. Let's do example 4. Okay. Which of the following exponential functions best represents the graph below? Okay, the very first thing that I see about this graph is that the y-intercept is at positive 6. And that number right in the very front, that is your y-intercept value. So if we have a y-intercept at 6, that means the first number outside of my parentheses should be 6. It cannot be A, it cannot be B. It has the wrong number in front. They put 3. Well, that tells me the y-intercept. Now I've got to figure out if I want a number that's bigger than 1 or between 0 and 1. Well, look at this line. It is decreasing as it moves from left to right. It's getting lower and lower and lower and lower. That means that we need a number that is between 0 and 1. So you can always go back to this part. If it's between 0 and 1, it's decay, which means it's decreasing. So if it's got to be between 0 and 1, that means answer choice D is the best answer. Number 5. Which of the following exponential function best represents the graph below? Okay, so once again, I'm looking at this guy right here. I can see that the y-intercept is 2, and that's the number that's on the outside of the parentheses. So right away, answer choices C and D are gone just because they have the wrong number that's out in front. Now, as far as figuring out if it's this one or this one, look at the line. This time, my line is increasing. If your line is increasing, that means exponential growth, which means we are looking at answer choice A. That number inside the parentheses has to be bigger than 1 in order for it to be exponential growth. And you could even just plug this one in and graph it. You can kind of see that it matches. And if you had tried to do answer choice B, you would have been able to at least eliminate an answer, because you can see that the line is actually going the wrong direction for answer choice B. Last example, number 6. Which of the following graphs best represents the exponential function f of x equals 3 to the x power? Okay, a very common mistake on this problem, people think the y-intercept is 3. It's not. The y-intercept is actually 1. And the reason why is that this equation, or this function, is not actually written in this format. If I was going to write it like this, it would be f of x or y, it doesn't really matter, but I would have a 1 on the outside, parentheses, 3 to the x power. Now that 1 necessarily wouldn't actually be there, but we know in algebra there's a lot of times there's imaginary ones that are in the front of parentheses. That's what that is. So that's why the y-intercept is actually at positive 1. So answer choice A is okay. Answer choice B has a y-intercept at 3, get rid of it. This one has a y-intercept at 1, that's okay. This one has a y-intercept, I don't really know, but it's definitely not at 1. Looks like some kind of fraction or decimal, so get rid of it. Okay, now between my two answer choices, answer choice A is going up, answer choice C is decreasing. Well, if you look at that number that's inside your parentheses, if that number is bigger than 1, that means that your graph is increasing. That's growth. Okay? And once again, if you were not sure, you can always come over here and do 3 to the x power. Now, I know not everybody has calculators, but there is a calculator that has been embedded in this assignment so that you can check your graphs.